Everyone. Today I'll be discussing about the work that I've done so far on the analysis of heart study dataset to predict the individual and overall risk factors involved in developing coronary heart disease in the next 10 years. So, most of you might have known that half a million deaths in the United States and even in a lot of developing countries occur due to coronary heart diseases. So, the early detection of coronary heart disease can actually result in designing effective preventive measures and also in minimizing the effect of disease in high risk patients by probably modifying the lifestyle of the patients uh, in the earlier years itself. So, talking about the data recorded a lot of information with a lot of interesting attributes. So instead of just focusing on a group of similar set of features, the data comprised of three different sets of features of the data. So the first one is actually the demographic factors, which explained about the age and gender of the patients, and the second one was the behavioral factors, which explained about the behavior of each case. For instance, if the is a smoker or a non-smoker, and the third one is the medical condition of each case, indicating if each case had any diabetes or cholesterol and what is the BMI of each case and information like that. So, looking at the structure of the data, so the data is actually a combination of a lot of categorical variables with two levels and a lot of numerical variables also. So, if you look at the distribution of the data set, so this is how the data is distributed. Each variable were actually not equally distributed and they even had missing values. So this is actually the result of the data set after imputation, which will be done in the further steps. And so the next step is actually data preparation. So in this phase, data is actually processed, transformed, standardized, imputed, and even feature selection is done to make the data ready to pass it into the construction phase for modeling. So the first step in data preparation is data exploration, where the data variables are visualized to observe any patterns between the variables in the data set. So one of the interesting pattern that I observed was in the medical condition sets of variables. If you have a look at the bar plot that I created with the medical conditions, so this is the bar plot, and so based upon various variables, it was constructed. So if you look at the x-axis, it is the coronary heart disk risk variable, which is a categorical variable. 0 indicates absence of risk and 1 indicates presence. So if you look at the presence of risk variable, uh, the gray indicates cholesterol and blue is actually the heart rate. So the cholesterol seems to play a major and a huge impact in creating coronary heart disease after 10 years, which is evident already in the scientific community because cholesterol is a major cause of heart diseases. So even box plots were created to detect outliers. Z-score was found. Uh, Z-score was found to detect outliers again, and the data was normalized using min-max normalization. Imputation was done. Mean imputation of the numerical variables was done with respect to the gender variable, and mode imputation was done for a categorical variable with respect to the gender variable. So finally, PCA was also done in this case. I was actually curious to check how it's going to choose the features, but it wasn't implemented in the actual data set because the features were not that complex. And so 7 components were chosen by PCA for this data set. Uh, So before going into the model construction phase, that is a small phase, that is data partition. So data is actually partitioned in this case into 75% of the training data set and 25% of the testing data set. So the data was actually random, so I didn't use any data partition function, but I uh, partitioned them through a path value. And moving on to the next phase, so the data is actually processed, transformed, standardized, imputed, and it is ready to move on to the construction phase. So the models that I've chosen for this data set was k-nearest neighbors, decision tree, that is model regression tree, and support vector machines, and also binomial regression. So the major reason for choosing these four approaches was because the data target, that is the target variable, is actually a nominal prediction, and we have a lot of numerical data in it. So this situation works best in the following four approaches. So let's move on to the approaches to see how the algorithms performed. So the first one is k-nearest neighbors. So the most crucial feature in KNN is the k-value, and selecting k-value is another crucial part. So instead of just choosing a random value and just taking square root of the number of rows, what I decided to use a vector of k values and implemented the k algorithm for each k value passed in and created a cross table to evaluate the performance of the KNN model, and sensitivity was determined. So, and ggplot was done between sensitivity values and k values to see which one worked best. And k is equal to 12 surprisingly gave really good results. And cross table was done. That is, an evaluation metric was performed on the testing data set to see how well the algorithm performed. Sensitivity and specificity were determined. So the sensitivity was actually 99%, which is really high, and specificity was actually 66%. So the number of true negatives predicted were 900, and the number of true positives predicted were actually 151 cases. KNet proved to be an excellent algorithm for this set of data with lesser specificity, and AUC and tenfold cross validation was also performed on the data, and the accuracy was found to be 85%. And the AUC value was actually 97%, indicating that this could be one of the good classifiers. Moving on to the next approach, which is the support vector mission approach. So the one of the crucial features in this case is actually the kernel type function that we're using to build the SVM models. And instead of just restricting the model to one particular kernel type, I wanted to know which kernel type fit the data really good. So I tried implementing SVM through KSVM function of the kernel lab, and tried creating models based on different kernel types. And out of all, the Gaussian RBF dot seemed to perform really well. Predictions were made on the testing dataset, and confusion matrix was created to evaluate the accuracy. So the accuracy was 85%. It was almost similar to KNN. I mean, the K-fold validation accuracy, and the sensitivity was also really high. So if you look at the AUC value, AUC was basically helped in evaluating each algorithm. So the AUC was actually 51%, which was quite low compared to the KNN. And the K-fold validation also provided an accuracy of 85%. So the AUC was played a crucial feature in this case in not much giving details of the statistics, but it was able to see how well the algorithm worked in classifying, choosing between two negatives and two positives. And moving on to the next model, which is the GLM model. So in this case, the target was the dependent variable, and regression model was built based on all the features in the dataset initially, and variables with less significance values were eliminated using backward elimination approach, and a model was fitted. And looking into the summary, we could see a lot of significant variables in this with the intercept. And so these were the variables that uh, are known to be the ideal predictors for the target variable in this case. And predictions were made on the testing data set and confusion matrix was created. Surprisingly, overall, all the accuracy was around 85 to 84 percentage, and the sensitivity was really high, indicating that all the algorithms worked really good. And the root mean squared was considerably low. The UC was actually 73%, indicating that this could be a really good classifier, uh, probably after the KNN algorithm. The k-fold validation accuracy was 85 percentage. So the fourth algorithm that I implemented was regression tree, and the main purpose for choosing this algorithm was because so after building the binomial regression model, I wanted to visualize them as a decision tree structure, because the data itself comprised of a lot of conditions stating that if the case has this and this, it might result, and if it doesn't, it might not result. So I just wanted to view that in a decision making structure with linear models constructed in each terminal node. And surprisingly, uh, so the regression tree provided the ideal predictors. In this case, they were similar variables of the binomial regression that was created earlier. So, confirming that these could be the ideal predictors, and the combination of these factors could result in a really good significant model for the target variable. So, K-fold cross-validation was done, and confusion matrix was created to evaluate the accuracy, and even the accuracy was 85%. That was also very surprising. The AUC in this case was 74, so indicating that this could serve to be an excellent classifier for the data set. So the next is actually the model ensemble. So in this case, all the four learning algorithms that I implemented were taken together, and an ensemble model was created to do predictions on the testing data set with the ensemble stack model, and to see how it predicts, and to see the risk of each algorithm on the model ensemble. And surprisingly, the risk and coefficients were listed for each algorithm. So this was actually done using superlearner package, and KNN seemed to have an overall risk. Even though the AUC value was around 97%, the risk was even higher in this case. So AUC probably cannot be the only evaluation metrics through which algorithms should be um, computed. So even though all the algorithms was plotted to see how it worked, and to be the as I mentioned before, the linear regression worked really well with the superlearner ensemble model, and it seemed to be the best of all, since individual effect on the target variables are discovered by the linear model part. So I would tell a lot of evaluation metrics have been carried, and there is no one such ideal model that could fit a data set. So the data set should be analyzed in all possible ways with all possible evaluation metrics and see where a positive or negative thing could come. So moving on to the next phase, that is the deployment phase. So in this case, an interactive Shiny app application was created where the user can embed data. So in my case, my data is the heart study data, and the data will be processed and displayed as an output in the interactive web application. And also the machine learning outputs. So the user will be able to choose a particular machine learning algorithm on the user interface, and so in the background, functions will happen, and the output will be the performance of each model on the data infed. So thank you for watching this video and hope you enjoyed it.